Hi everyone, thank you for your patience. Here are the solutions for the practice exam. The angle 280 degrees. Start with the initial ray. Positive direction 90, 180, 270. About 10 more degrees gets us to 280. This little guy is 10 more degrees. The complement, which is the reference angle, is 80 degrees. The reference angle always positive, always to the horizontal, never to the vertical, even if the vertical is closer, always up to the x-axis. This, notice I put an arrow on the initial ray, the terminal ray, and this direction arrow on the angle itself. Two angles, one positive, one negative, that are coterminal. We're looking for angles that end in the same place. So 80-degree reference angle in quadrant 4. If you go in the negative direction, you hit one right away, minus 80 degrees. If you go in the positive direction, you're looking at, you go this way, you hit one here, but that's 280. We already used that, so we'll go around again to here. There's my next angle, positive direction with that terminal ray. That would be 280 plus 1 times 360. And that's 640 degrees, and of course I could use 2 times 360 to get 1,000, or 3 times 360 to get 1360, and so on. Every integral multiple of 360 from here on out would give me an angle that ends in the same terminal ray, and the same thing is true in the negative direction. The next one would be negative 440, and so on. These are just the easiest two, but not the only two. All right, next question. Are they, is true or false, all angles coterminal with 280 have the same trig values, trig function values? This is absolutely true. The reason it's true is because alpha is the same and the quadrant's the same. If we know alpha and we know the quadrant, then we know the trig functions, right? Regardless of what angle it is, how we got to that terminal ray. If alpha is the same and the quadrant's the same, another way of saying it is same terminal ray. Coterminal angles have the same terminal ray, so they're going to have the same alpha, the same quadrant. Or yet another way, you could say this. You could say this. You don't have to say all of them. These are ors. Or this. Or you could, some people would say that x comma y, the point, and the distance from that point to the origin could be the same, depending on what point we choose. And if we pick a different point on the same terminal ray, everything will scale so that the ratios y over r, x over r, and y over x would be the same. So no matter how you slice it, you're going to get the same trig functions if you end up on the same terminal ray. We already marked the reference angle. It's 80 degrees. Secant 280, if any trig function of any angle, again, is the same thing as is equal to that same trig function on its reference angle, except for a possible change in sign, the plus minus sign. It could be plus or minus. We're not sure yet because we haven't explored the quadrant. But in terms of magnitude, absolute value, it's going to be the same. The secant is defined as 1 over the cosine. So we can actually write it that way. Secant of 280 is 1 over the cosine of 80. Now we can investigate the sine. We're in quadrant 4. In quadrant 4, the x values are positive and the y values are negative. So the cosine is, that's supposed to be a positive sign. I don't know what that looks like. The cosine is positive, the sine is negative. So the cosine being positive means I could put a positive here, and you can leave it there if you like, but you don't really need it because it's positive by default. And there's your secant 280 can be written as 1 over the cosine of 80. That's a trig function in terms of its reference angle. In terms of a trig function of its reference angle. Negative 90 degrees starts at the positive x-axis, as do all of our central directed angles. Here's my initial ray. Go 90 degrees this way. I end up down here. And I'm supposed to pick a point anywhere on this terminal ray I choose. It doesn't matter where we pick it. Most of the time from here on out we're going to pick 1 because we know about the unit circle now. But let's say I picked 0, -4. That's certainly on that negative y-axis, or that terminal array. It is 4 units away from the origin. So this is, there's x, there's y, and there's r. So sine of minus 90 degrees would be y over r, which gives me -4 over 4, or -1. The cosine of minus 90 degrees is x over r, which is 0 over 4, which is 0. And the tangent of minus 90 degrees is y over x, which in this case is -4 over 0, which is undefined. You can't divide by 0. Remember that 4 over 0 is undefined, whereas 0 over 4 is just 0. You can divide into 0, you cannot divide by 0. The cosecant, the secant, and the cotangent of minus 90 degrees are just the reciprocals of those 3 values. So the reciprocal of -1 is 1 over -1, which is just -1. 1 over 0 is undefined. And this thing actually started out as -4 over 0. So when I flip it, I get 0 over -4, which is 0. So there are your 6 trig functions. -1 is the sine, 0 is the cosine, the tangent's undefined, the cosecant -1, the secant is undefined, and the cotangent is 0. Moving on to -210. This one is not a quadrantal angle. It's going to end in the middle of a quadrant, so we're going to have to use either the point on the terminal array. We'll find the point on the terminal array by using the reference angle and the trig functions of the equivalent first quadrant angle. So -210, we start as we always do on the positive x-axis. We go this way. That's 180. So we need 30 more. So a third of the way into quadrant 2. That's the angle theta equals -210. This right here is its reference angle, and that's 30 degrees. There's 30 degrees back to the horizontal at 180. So the trig functions of -10, we're in quadrant 2 here, where the x values are negative and the y values are positive. So this is cosine, remember. This is sine. So the sine of -210, we get the magnitude from the sine of 30, which is 1/2. That's a half. And then we get this SIGN from the quadrant. Sines are above the x-axis, y's are above the x-axis, so it's going to be positive. The cosine of -210, notice cosine of -210 is the x over r, it's the cosine of 30 degrees, which is square root of 3 over 2. And it's negative. It's to the left of the y-axis, so that's a negative. And the tangent of -210, again, we use the equivalent ratios in quadrant 1 for 30 degrees. So the tangent of 30 we learned in unit 1 is √3 over 3. And that's going to be negative because it's a positive divided by a negative. So the tangent's going to be a positive over a negative, which is a negative. The reciprocals are familiar again from unit 1. This is 2 √3 over 3. The first one was 2, and the last one is 3 over √3, which rationalizes to √3. When I flip the fraction, the sign doesn't change, so the sign carries over when you go to reciprocals without change. And this one's called the cosecant, this one's called the secant, this one's called the cotangent. And I'll leave the -210 out in the interest of time. There it is. There are my 6 trig functions of -210. Here, this is a first unit problem combined with a second unit problem. So here we're talking about first we're talking about the magnitude. We did this in Unit 1 when life was all in quadrant 1. So we're not talking about central directed angles. We can just look at the equivalent right triangle, this angle being alpha, the reference angle for theta. It may not be the same angle. It may be in a different quadrant. It may have gone around the system a half dozen times. Doesn't matter. All that matters is that we're going to find the point of the terminal array using that same reference angle. Adjacent to alpha is 1. The hypotenuse across the horizontal is 4. This side we don't know. We compute it using the Pythagorean theorem. So y squared is equal to the square root of 15. This is root 15. Now we have all the numbers we need to generate the trig function, the magnitudes thereof, but we have to adjust those for the quadrant, which gives us the SIGN, whether it's to the left or right of 0. And this is the unit 2. This is what's new, so don't forget to do this, because this is really all that's new for this unit. Every year I have somebody who says, I got everything right but the sign, and I have to inform them that there really wasn't anything to the second unit but the sign, so you really do have to get the sign right. The cosine here is positive. That means it's to the axis to the right of the y-axis, so that means these two quadrants are in play. The tangent is negative, so tangent is negative. So we know that the tangent's negative in quadrants where y and x have opposite signs. This one's positive over positive, so it's going to be positive. This guy's negative over a negative, so it's going to be positive. But here we have a positive over a negative, so this is negative. And here we have a negative over a positive, so this one's negative. When the signs are mixed, the tangent is mixed. So this is the quadrant we're in here. We're in quadrant 4, sorry, because that's the quadrant, that only quadrant that satisfies the condition that the cosine positive and the tangent is negative. So we put all this together now to write down our trig functions. The sine of theta, whatever the heck theta is, we don't even know. All we know is what its reference angle is, roughly, there's alpha, so the opposite side is root 15. There's the hypotenuse, so it's root 15 over 4, and this piece here tells me that the sine is going to be negative, right? It's got to be in quadrant. It's got to be negative in quadrant 4. The cosine of theta is adjacent over hypotenuse 1 over 4, and the cosine in quadrant 4 is positive, so we get a fourth, as we should, because that's what the problem told us we should get. And the tangent of theta is y over x. That is root 15 over 1, which is just straight up root 15. And then again, since we're in quadrant 4, the tangent is negative. So that's negative root 15. Then we look at reciprocals. This one, when we flip, is going to be 4 over root 15, which rationalizes to 4 root 15 over 15. This one rationalizes to, this one's just 4. And this one rationalizes, 1 over root 15 is the same as root 15 over 15. And the sine is negative, sine is positive. These are both positive, and this one is negative. This one's the cosecant, this one's the secant, this one's the cotangent. And again, I'm going to leave the parentheses of the value out here. All right, and moving on. Moving number 6. Convert to radians. So what you want to think about here in your mind's eye is here's a circle with radius 1. It's the circumference of this thing is 2 pi r, which is 2 pi times 1, since the radius is 1. So all the way around this thing is 2 pi, so that right there is pi. This length right here on a circle of radius 1 is about 3.14 units long. So if that's an inch, this would be 3.14 inches if I straightened it out and laid it down and measured it. So pi is the same thing as 180 degrees, a straight angle. So pi equals 180 is all you really need to remember. To find the first one, we just divide by 3. 180 over 3 is 60. So in radians, that's pi over 3 units. The length of that arc right there is pi over 3 radians. That length right there is pi over 3. It's a third of pi. 240, easiest way to handle 240 is just to remember that, put it in terms of an angle that you know, it's an easy multiple of 60. So always try to write these as a multiple of 30, 45, 60, 90, something that you already know that's easy to come up with. This is 4 times pi over 3, which is typically written as 4 pi over 3, although it doesn't have to be. You could leave it like that if you like. So there are those two answers. And then this guy here is a little trickier. You have to recognize 510. The easiest way to recognize this is that 3 times 17 equals 51. If you recognize that, then it's pretty easy to jump to 30 times 17 equals 510. Just add a 0. If you don't, well, let's finish it this way first. So it's 17 30s. That's 17 times 30 degrees, which is 17 times, how do I get 30 degrees? Well, 30 degrees is a sixth of pi. So to get to 30 from 180, to get to 30 from 180, I divide by 6. So if I divide pi by 6, I get 100. I get the equivalent of 30 degrees in radians. So this is 17 times pi over 6, otherwise known as 17 pi over 6. You could just as easily, if you don't recognize 510 as a nice multiple of 30 right off the bat, you can always use the conversion formula, which would be take the angle in degrees, 510 times the angle in radians, pi radians for every 180 degrees. And simplify this beast. When you simplify, you're going to get that, because there are you can take 17 30s out of 51, and you can take 6 30s out of 180. Divide top and bottom by 30, and you got that. This is going to go out. It's going to be units are going to be radians. You get 51 over 18. This divide this thing by 3, you get 17. Divide this thing by 3, you get 6, and so on. So you just have to, if you use the conversion formula, you end up having to do a lot of canceling, but it's not wrong. Convert to degrees. So pi over 2, just think that's 180 over 2, which is 90 degrees. This guy a little trickier. It's minus 7 times pi over 3, which is minus 7 times 60 degrees. Pi over 3 is 60 degrees. And so this is equal to 7 times 6 is 42, so it's minus 420 degrees. That should be a minus sign. That's the easiest way to get that guy. 10 pi is just 10 times 180 degrees, because pi is 180. That gets you 1800 degrees. Alright, so don't forget there are 3 parts here. So the first part is to draw and label the indicated arc. So 11 pi over 6, we're dividing, this is minus 11 times pi over 6, which is minus 11 times 30. If you're thinking in terms of degrees. So 1, we're going this way, it's positive. No, it's negative, sorry. Negative. So we got to go this way. So that's 30, 60, 90. It takes 3 of them to get 90. And then 4, 5, 6, takes 6 of them to get 180. 7, 8, 9, takes 9 of them to get up to 270. And then 10, 11. So that's 300 degrees. It's 30 degrees short of being all of 360. But we're not thinking in terms of degrees anymore. We're thinking of arc length. So we send our PE student running along the circular track at this point right here. And we keep yelling out, "Where are you? Where are you?" When they get to here, they stop and we yell out, "Where are you?" And you respond, "I'm at square root of 3 over 2 comma 1/2. How did I get that? Well, because if I draw a radius here of length 1 and drop a perpendicular down to the x-axis, that's 30 degrees, because we're 30 degrees short of 360. So I'm looking at a 30, 60, 90 right triangle. This side would be root 3 over 2. That side would be a half, since I have 1 on the hypotenuse. So to find a coordinate point, you go out x units, which is square root of 3 over 2 units, and up a half unit. That's where this is coming from. So now I've drawn and labeled the arc. I should label it. S is the arc. It's this path highlighted in blue. The label, the coordinates of the point, I did that right here. Maybe I should use a different color to make sure you realize that there's 3 things required each time. And the last thing is to come up with the value of the trig function. So don't give me 11 pi over 6. That's just that's the arc length. I want to know what the tan of 11 pi over 6 is. Tan of minus 11 pi over 6 is equal to the y over x coordinate. Tangent is y over x. So we just look at these guys. It's a half over the square root of 3 over 2. They're both positives. The tangent's going to be positive, and we've simplified this enough times to know that's 1 over root 3, which rationalizes to root 3 over 3. That's the third piece. Again, I should use a different color, so you know it's not just one problem. One part is 3. This is root 3 over 3. There, and that arc right there. Those are the three things you need to complete the answer.